Welcome! In this series of videos, we will look at the design of systems using the PowerBasic, Windows and console compilers. Today, we will look at starting to design the monitoring application for your cluster. Over on my hardware channel, I've been detailing the work done to create the computers that will be used in this cluster processing project. The work on the Odroid computer rack has now been completed. But today we are going to talk about the approach to designing this software system. The monitoring process is at the heart of the system, deciding what work needs parceled out to each of the worker computers in the cluster. It can do this by monitoring the database to see what work is needed and updating a table in the database from which the worker computers read their to-do list. The monitoring process has several tasks to perform. The worker computer's status is read from the database, allowing the monitoring process to decide which computers to allocate tasks to. Today we're going to look at displaying the status of the system and each worker computer. As the database for this project is stored in SQL Server Express, we will be looking at the one table that contains the data we are interested in, and creating the SQL scripts to read it. The Warp Core Monitor process is going to have two things to do. The first is to allow the person monitoring the system to see the status of the system. The second is to allocate tasks to the worker computers. To speed things along, I've created a template for the Warp Core Monitor. What we have here is a very simple PowerBasic Windows application. If we have a look at PowerBasic Forms, we can see we have a single dialog which has a menu control, which at the moment only allows you to exit the application. It has a graphics control, and it has a status bar. All the information we're going to be showing to the user will be on the graphic control. As you will see, we've included a few libraries with this application. I've added in the SQL Tools libraries at the top. The SQL Tools libraries are a purchased application, and these will not be in the Windows zip file on the GSF software website, but I will include a link below to where you can actually purchase them. The remaining libraries will be in the zip file. These are the generic SQL functions, the XML library we did in our last video, a PB process library, which allows us to see which processes are running on a computer. This is a library we created some time ago, and the PB file handling routines, which we've made heavy use of. We're going to add another library to that list, the date functions library. Now, having put all those libraries in place, the next thing to do is have a quick look at our PB main function. The PB main function will call the forms initialize common controls first. In later videos, we'll be making some use of some random numbers. So we're randomizing the random number generator using the timer. Because this monitoring process will be the process which allocates work to all the worker computers, there should only be one of it running at any one time. So we're using the process count function from the process library to ensure there is not more than one version of this application running at a time. If there is, the application, which will be number 2, would automatically end. It's always a good idea to have a log file to which you can actually log statuses or problems with the application, so we've created a global variable called strlogfile to contain that information. The file is named using two standard constants, the exe path, which is the path to where exe currently sits, and the name of the executable. We're tacking on to the end of that an underline log.txt. The next section of code is the authorization for the license to use SQL Tools. If we have a problem with that, we're logging to our log using our standard fun log function. Having done that, the next thing to do is to initialize the SQL library itself. Once that has successfully been done, we can attempt to connect to our database. Now, as we did in the Warp Core program, we're using a SQL username and a password. Now in a future video we'll be slotting these into a configuration XML file, but for the moment they're just hard-coded in the application for the moment. And the database we'll be connecting to will be Kronos, just the same as we did with the previous design program. So we have two options on the connection string. We can connect using either a username and password, or we can use trusted connections. Today we'll be using the username and password. So in the connection string we're building up the string to say the driver we're using is SQL Server, the username is Kronos, the password is Wombat123, the database is Kronos, and the server we'll be attaching to, which contains SQL Server Express, is Quad1. We're using the constant of db to define the database handle, in this case database number 1. We're then calling the userdbopen function to attempt to open our database, and it will return a status value to let us know whether it's opened or not. It will also return a true value if it has successfully connected and a false value if it did not. The details of the failure will be in str status. So if the database does open OK, we're logging our status to the log, and then we're calling our dialog. After the dialog has been completed, in other words the user has closed the application down, we will close the database and log the fact that we did that, and we will shut down the SQL library. And the application will then end. Now, there are going to be some globals we want to set up. We've already set up one constant for the database handle and a global to contain the name and the path to the log file. In addition to that, as we're going to be using the graphic control, we want to set which font we want to use in that. So I'm going to set a global up to define our font handle. Now I know we haven't done a great deal on fonts, but they are quite straightforward. So what we're going to do in our pb main function is we're going to define our font. This is quite easily done with a font new command, specifying the name of the font we want to use, the second which is the point size of the font, and we're sending that as a result to the handle. This we can use later on in the code to actually access this font. Now because we defined a font in memory, when the application finishes we'll want to release that memory again. So before we finish the application we will use a font in command to free up that memory. So now we've got that far, we need to have a look at the dialog itself. In the initialization handler section, we can put the code that we want to execute. This will be the code which displays on the screen the status of all the computers which are currently participating in our cluster. If we just put the code in here, it would only execute once. However, we'll want this display to be constantly updated. So we're going to be using a timer. So we're going to set a static variable up at the top of our function called htimer, and we'll set this as a quad. And we will create a new event underneath our initialize dialog, which is a timer event. So in here we will put code we want to execute whenever this timer times out. So in order to get the timer to trigger, you need to give it an interval. So we're going to use a Windows API call called setTimer. Calling setTimer, you'll give it a number of parameters, the first being the handle of the dialog, the next being a 1, and the next being the interval. Now this is the number of milliseconds, so this is going to trigger every 60 seconds. So every 60 seconds we're going to call whatever code we put in the case WM timer. So we will start off by initially displaying the status of each computer. So we need a new function to perform that. We're going to call that populate work cores. We'll give it two parameters, one being the handle of the dialog and one being the handle of the graphics control that we wish to populate. Now this will be exactly the same information which gets triggered every minute. So we will also copy this into here. so that every 60 seconds the graphic control will be updated. So all we need to do now is to declare a new function, taking the two parameters, the dialog handle and the graphic control handle. Now this is going to be pulling information back from the SQL Server Database. So we're going to need a few variables to handle that information. So before we do any other work, let's have a look at the SQL Server Database. So here we are inside SQL Server Management Studio. We have only one table in the database so far, and we have selected all the information within that table, which is a single row, as we only have one computer in the cluster at the moment. This computer has actually stored its machine name, the date and time it updated the database, the amount of disk space free, the total disk space it has, and since this particular machine is the one holding the database and the main archive, it's showing information from the archive area as well. So we're going to create a store procedure whose job it is to pull this information back for us. So to create a new store procedure, we go to the Programmability section and Store Procedures. Now there is one store procedure there already, so we're going to be creating a new store procedure. This displays a template, which is quite easy to use. We will give our new store procedure a name. We'll call it SPR Get Warp Core Status. Now this one is taking no parameters, so we can get rid of this section. And we want to put in the fields that we wish to select from this table. Now if we open this up, we can quite happily drag the columns in. So we'll pull in the first column. And we'll pull in the machine name. Also pull in the heartbeat information, the disk space free, the total disk, and the last two columns as well. Now we need to tell it which table this is coming from, so use a from command, and we can just drag in the name of the table. And if we want to order this in any particular order, which we will, we'll do an order by, and we'll order it by machine name, ascending. So if we just select this set of code and hit execute, it will show us the information it's going to pull back, which is exactly what we're after. However, rather than pulling back just the heartbeat, we want to pull back an active or an inactive status. So we're going to do something a little different on the heartbeat. So we'll just push that down to a separate line, and we're going to use a case statement here. And when the heartbeat itself is less than 15 minutes old, then we'll say the machine is active. Otherwise, we'll say inactive. And you can do this quite happily using the date add command. And we're interested in minutes, and we're looking for values in the last 15 minutes. And we can use the inbuilt get date command to go back the date time. And then if that's the case, we'll return active in single quotes. Otherwise, we will pull back inactive. Now if we run that piece of code, we would see this is currently shown as inactive because it is older than 15 minutes ago. The reason for this particular status is we want the monitoring application to monitor for the machines which are currently active. And for those which are active, it can give additional tasks to. For those machines that haven't put a heartbeat in the last 15 minutes, these machines are either very busy doing something, or the machines are no longer active at all. They may well have been switched off or performing something like a Windows update. So having got this information into our store procedure, we can then execute the whole thing which will then create our store procedure. So if we go back to store procedures, right click and refresh, we will see there is now a new get warp core status store procedure sitting there quite happily. So now that we have that in place, there may be one other thing we actually need to do. We're looking to see whether it's active or not. We're not actually saying at this point in time how many tasks have been allocated to that machine. Now that information isn't actually in this table, but we could do a subquery to pull it from somewhere else. We don't have any more tables yet that would contain that information, so for the moment we're going to return that hard-coded to the value 0. And we'll just call that count. So if we just sort out this store procedure to be the way I expect it to be, well, we've set a variable up called strSQL, and this is what's going to contain our SQL. Now you don't have to put exec, as in execute, at the beginning of all your store procedure calls, but I find it quite useful because it allows you to easily find all the store procedure calls within your application just by searching for that string. Now we've already created routines in the previous videos that will allow us to pull back information from a store procedure in the database. And this is this get generic SQL data function. So we're passing it a number of parameters. We're passing it the SQL, which we've just defined. We're passing an array into which we want to put the data, which we've defined up here. We're passing it the database handle, and we're allowing it to pass back an error value should it encounter an error. Now, if there is an error, we may want to push this error out to our log. And we will give it two pieces of information. We will give it the SQL string we were trying to execute, and the error message itself. Assuming the store procedure actually returns some information, we can then look to display that on our screen. So as we're going to be populating a graphics control, there is some information we want to set on it. Now we've already set the background to black, but if we set the colour to be green for the foreground, this will allow us to have green text on a black background. We can then set the location on the graphics control where we're actually going to be writing. We'll put this up at the top left hand corner. We can define the font we're actually going to be using, and we're going to use this set click command as well to prepare our graphics control for use. And since this function will be running every 60 seconds, the one thing you'll want to do is to clear the graphics control so there's nothing from the previous run lying around on screen. Now as we're going to be printing to the screen, and there are hopefully going to be a number of computers in our cluster, we'll want to actually have a row counter. So we've set up a variable called long row. And the first thing to do is we will increment that value to make it 1. And then we're going to set the graphic row to which we're going to write to be that number. So we're now setting graphic row to number 1. Now we'll want a title at the top of our graphic control to say what we're actually doing. And we're going to print out the warp core monitor, the current time, and the current date. Current date coming from our date library. We'll then increment the row counter, and we'll put the heading in for our data. For example, the computer, the status, the current disk usage, and the time. We'll do another increment. We will then set the row to be what that increment value actually is now. Now we will pull back information from our array in a for next loop. So as the first column is going to be our computer name, we can pull the computer name out of our array using the parse command. So we're parsing on the element of the array. All the data coming back in the array is pipe delimited, and we're looking for the second column. Now the second column is the computer name. Now, as we set the status as being active or inactive, we can then set the color using the graphics color command. So if the status is inactive, we're setting the color on the graphics control to red, otherwise we're setting it to green for active statuses. Having prepared the color to be either red or green, we can then print the status out to the screen. Now we're using a pause command on this print to print at position 390 without a carriage return at the end. And we can then force the color back to green just in case it is still at red. And now we can print out our time slots. Now these are all going to be 0 at the moment because we haven't yet defined how to give work to the worker computers. And this will go to position 520. This way you can set the positions on the line quite easily. We can then test to see if the computer is actually the computer which holds the archive. And if this is that computer, then we can print out the information that the disk computer has. Otherwise, we'll just leave it as blank. So before we go any further in this code, it's worth doing another compile to make sure we haven't missed anything, which we appear to have done. Yes, we have not yet set up the globals for the disk server. And we will slot in the globals for the disk server. And another quick compile. And close. Right, our code is now successfully compiling. We've missed the command to print out the computer name itself, which needs to go in here. So we've got the computer name, the status, which is inactive as expected, disk users we haven't covered yet, the number of worker tasks passed to this machine is 0, and the log storage is blank. So we've got 3 of our columns populated. So what I want to do for the amount of disk space on the machine is rather than display it as a number, I want to display it as a graph. So what we're going to do is we're going to pick up the values from our store procedure and we're going to put them into variables. So we're picking up the amount of disk free, the total disk, and the total disk used. And this will be a percentage. And we're going to display this using the graphics box command. We'll just step through this when it's actually doing. So we're drawing a graphics box using this offset command, and we're marking it as green. So if we try running that now, we will see we're getting a green box. Now this is what would be 100% of the disk space. All we need to do now is draw another box on top of the first box to show the amount of disk space used in red. And this will quite easily show on screen a graph. We will find we now have a small graph to show us the disk usage on this computer. Now all we need to do is to complete the log storage. So we merely have to set up the disk server. So where we've populated all our other constants, we will slot in our disk server as well. And we will want to set up the drive letter. And if we try running this now, we will then see how much log storage we'll have. So this allows us to monitor, at the moment, a single computer. So as this information should update every 60 seconds, we can add more computers to the list. So let's spin up another machine and add it to our list. So we're now on a new computer, COD 002. We have the Warp Core executable we created in our last design video. So if we try running that now, it has successfully connected to the database and has done a heartbeat. So let's have a look at our database to see if it's actually reached it. So the warp core monitor, which is refreshing its screen every 60 seconds, has successfully picked up the fact that Quad 2 is now active, because it has updated its heartbeat in the last 15 minutes. And it's also displaying its disk usage. So this is the first part completed of the warp core monitor. This allows us to display each computer that's in the cluster, whether it is active or inactive, how much disk usage it's using up on its Windows drive, and how many tasks, in this case time slots, have been allocated to the machine for processing. In the next video, we will look at allocating tasks to the machine. But that's it for today. Thank you for watching.